My name is Arnaud Le Hors. I'm part of the Open Technology Group at IBM. I'm an open source, open standards specialist, and for the last 2 years plus, I have actually been focusing on security related to open source, primarily focusing on the OpenSSF, the Open Source Security Foundation. So the good news is that open source has become a critical part of the software supply chain. Studies after studies come out with an increasing number of the percentage of open source being used in applications across the board. The problem is the number of attacks against open source is equally increasing. We have actually seen an explosion of vulnerabilities being exploited through the open source supply chain. So this is a problem that's bigger than any single company can tackle. This is why, as a whole, we have decided to create organizations such as OpenSSF, and there are others like OWASP and others, to try to tackle this problem at the industry scale level. The governments around the world have taken notice. Obviously, the increasing number of attacks is having a serious impact, economical impact, but also, it costs money, but it also creates problem with personal information being leaked, privacy invasion, and so on. So we've seen, like, for instance, in the US, there was an executive order that requires S-bombs. S-bombs are software bill of materials. The concept of bill of material is fairly old. It's used in many industries. It basically provides some form of attestation of what kind of components and the provenance of the components are in a given product. So software bill of material, the adaptation of this concept to software, because the first problem we have as an industry in general is that when a vulnerability is being disclosed, people have a hard time even knowing whether this actually impacts them or not. Does the component for which a disclosure has been made is even used in a product? Most of the time, people don't know. So this is what this requirement having an S-bomb will move the ball forward by saying, well, if at least we can tell which components are used in a product, customers will be able to make a quick assessment as to whether this is of a concern to them or not. But and there are other regulations all around the world being in the works at different stage of adoptions. In the EU, we have the Cyber Resilience Act, which is basically in its final phases of adoption by the European Parliament. And it also puts an end to the basically use at your own risk kind of license that we have become familiar with in the software industry, but which is at odds with everything that's done in other industries like the automotive industry or the food industry, obviously. If the problem is S-bomb is only just a little piece of the solution to the problem. Fundamentally, what we're trying to do is increase the security posture of open source at large. Obviously, if you have a vendor, you're buying a product from a vendor, you can expect that vendor to be responsible for fixing vulnerabilities that may come up in those products. When you use open source, whether directly or indirectly, well, who is going to be responsible for fixing problems that may arise from this code? The vendors obviously have to be responsible for their included in the product. So now if you're a vendor like IBM, you have that problem to say, well, we're importing all these open source packages in our product. We must figure out how to reliably use those components and make sure they are secure to use. So OpenSSF has a whole array of initiatives around development of best practices so that developers can be educated as to, what is the basics about developing in a more secure way, using memory safe languages when it's a possibility, and ensuring that throughout the development life cycle, we take security as a first class citizen and not just as an afterthought, which is typically, some kind of final check. We are also developing, as part of the OpenSSF, different tools. There are tools like scorecards, which will help people make an assessment as to the security level of a project. And this is not based just on scanning for vulnerabilities, the code. It actually looks at different criteria, which may include such things like, is this project even actively maintained? So it will look at signs for activity, how long issues are left open, how long, a proposal for changes are left open. And it will try, things like looking, does this project have a way to handle security disclosures in case there's vulnerabilities that is being found? Is there an easy way to contact the maintainer of the project that you have found a vulnerability, so that security researchers that find the vulnerabilities can document this and communicate with the maintainers of the project to possibly address the problems? But it's also things like, do they have a policy so that all the changes that are being made to the project, to the code, are being peer reviewed? These are the kind of activities that can be implemented in projects to improve the security posture of the project, ensuring a better quality product. It's also gathering information, ensuring that artifacts that are being produced can be signed, and there's a way to verify easily that the artifacts were not tampered with. And so we use techniques like, there's a SALSA, security level for software artifacts specification, that defines different criteria that build platform providers can use to improve the security of the build environment. And there are other extensions being in the works. All this is, information gets collected throughout the build process so that it can be attested, signed, and produced along with the actual software artifacts, and then later on verified by the consumer of this artifact. There are activities such as SIGSTOR. This is another OpenSSF project, which basically tries to make super simple the activity of signing artifacts and verifying them. This is something, has been done forever. I'm 60 years old, and, I've been doing software releases for a very long time. And I remember the times when we were publishing zip files, and along with them, there was a signature and a public key that you would publish to let people verify that this was actually the zip file that you had produced, or the tar file, and that nobody had tampered with this. But, this is well known. This is a trouble because people don't have the keys. They lose their private keys. And so it's a big hassle. And so the SIGSTOR project basically decided to tackle this problem, which has been around forever, and say, how can we make that super simple so that everybody can do that without getting headaches? And so they came up with this new approach called SIGSTOR, which is actually a collection of different tools that help make that kind of operations much simpler. And so this is the kind of stuff that's happening in OpenSSF that collectively we hope will improve the security posture of open source, and by definition the security of all software, because again, closing back on what I started with, open source is used widely in all software. So when we tackle security issues related to open source, we tackle security issues to all software, which will benefit all the industry as a whole and everybody out large, because software is in everything we use nowadays. Even your fridge might use a piece of software. So this is what it's about. I am honored to be part of this panel where we have people from the industry, different experts A lot of them I work with on a regular basis as part of OpenSSF, and we will be discussing these kind of issues with, again, the idea of, ensuring that basically raising awareness about this problem and the solutions that we're working on, because it's such a big problem, it will take everybody to play along and do their part for us to even have a chance to solve it.